In this video, we will solve this polynomial inequality. Before we get started, we really need to get 0 on one side. So I am going to subtract x from both sides and add 5 to both sides. So these two terms will wind up on the left, but they will be opposite signs. So that will give me x to the third power minus 4x squared. Now here comes the x, so I'm going to have minus x over here. Now remember, I'm adding 5 to both sides. So negative 1 plus 5, that's going to be a 4, is less than or equal to 0. Okay, once you have 0 on one side, the next thing you want to do is look at this as though it were an equation instead of an inequality. So I'm just going to write down the same thing, but I'm going to put equals 0. Now, by solving this equation, it's going to give us the zeros of the function. It's going to give us the x-intercepts. And those will serve as border points and, end points for our intervals. So we need to figure that out. Now, at a glance, I can see that grouping is going to work on this problem. I see the negative 4 and the 1. Right here, and negative 4 over 1 is negative 4. And here I see positive 4 and, negative 1. Positive 4 over negative 1 is also negative 4. When you get the same thing twice, you know that grouping is going to work. So let's get to it. Let's solve this by grouping. Okay, so if I group these two terms, the common factor is x squared. So if I pull the x squared out front, now I can talk about what will be left behind. If I divide both of these by x squared, that's going to leave x minus 4. Okay, now for grouping to work, I need the other parentheses to also be x minus 4. So let's sort of do that and then see why it's going to work out. Remember this negative 1? I'm going to go ahead and pull that negative 1 out. Now, with the parentheses, imagine doing the distributive property. Negative 1 times x, that would be this negative 1x. Now, negative 1 times negative 4 would be positive 4. So this is equivalent to what we had. Since the x minus 4 is a common factor, I can pull that common factor out front, and then that's going to leave behind the pink part, x squared minus 1. Alright, I'm hoping at this point it's jumping out at you that this is the difference of two squares. So x squared minus 1 can factor further as x plus 1, x minus 1. And I'm going to bring down my x minus 4. Okay, I also could have put this in my calculator and scroll down looking for zeros on the y side of the table, and I would have found the same zeros that I'm about to find right now. So this is factored form, but it gives me the zeros of positive 4 and negative 1 and positive 1. These are my zeros. Okay, so I've got negative 1, positive 1, and 4. Those will form the x-intercepts, which I will need to now plot on a number line. So I'm going to make a number line with these border points, these critical values. Alright, so let's say here, here, and here. So I'm putting them in order so that this would be negative 1, this would be positive 1, and this would be 4. Okay, because of the or equal to, the border points will be included, alright, because they represent where the function is equal to 0. And we're including the or equal to, so we will make these closed circles. If this had been just less than, then these would have been open circles. Okay, so I've got that. Now, I need to see in which zones are the solutions. So I need some test values, one in each one of these 4 zones. So over here to the left of -1, I'm going to use a test value of -2. Between -1 and +1, I'll use a test value of 0. Between 1 and 4, I'll use a test value of 2. And bigger than 4, I'll use a test value of 5. Now, I'm going to use my TI-30XS multi-view to help me get to the bottom of this. I will go ahead and type this equation into my calculator, well, this function. Let's clear that out. I've got x to the 3rd power minus 4x squared minus x plus 4. Now, I am going to leave my calculator in ask mode. Alright, your calculator might be in auto. I would scroll down here. It doesn't matter what the start value is. I would switch it from auto to ask and hit enter. Okay, because now we can put in whatever values we want. And I want these to be my test values. Okay, I'm just going to delete these to be really clear what's going on. So my test values are -2 and 0 and +2 and 5. So let's start with -2 and 0. Okay, so I could put in -2 and 0 at once. So that gives me -18 and 4 for the values of the function, -18 and 4. Okay, so here I've got -18 and 4. Okay, and the question is, are these values less than or equal to 0? Okay, so let's see, are they less than or equal to 0? Question mark. Less than or equal to 0? Question mark. Is -18 less than or equal to 0? Yes. All negative numbers are less than 0. Is 4 less than or equal to 0? No. 4 is bigger than 0. Alright, let's find the value of the function at 2 and 5 now. Okay, so I'm just going to go back up here and do 2, enter, 5, enter. So that gives me -6 and 24. Okay, -6, is that less than or equal to 0? Yes. I already forgot the other thing. 24. Okay, 24. Is that less than or equal to 0? No. Okay, everywhere I got a true statement. Everywhere you see a yes answer, that means the solutions are in those intervals. Alright, so over here to the left of -1, all of these values less than -1 will be solutions. So I'm going to just represent that with an arrow. This no means there are no solutions in this zone, so I'll leave that blank. Here's another yes. That means there are solutions here between 1 and 4. And this no means that this interval has no solutions. Now, I need to record my answer in interval notation. So, okay, see this right here, interval notation. So I have 2 intervals with solutions. To the left of -1, all right, this is from -infinity to -1. Okay, so this piece right here, I think I'll do this in purple. This is -infinity to -1. And we should use a square bracket because it is a closed circle. Now this interval is from +1 to 4. So it's from +1 to 4. And we should use square brackets on both sides. Closed circle, closed circle. When you have 2 intervals like this, you should use a union symbol to connect them. Okay? Now, looking back at the answer choices, before I look too hard, the software used to generate these questions, this author is using these braces. you know, this type of a thing, instead of square brackets, but they mean the same thing, or at least the author of this question wants this to represent the same thing. Okay, so everywhere I see a brace, I'm just going to replace that with a bracket, because I know that's what the author means. Alright, they're just using a slightly different system than we are. Okay, so to match it up, treat the braces as square brackets. So, having done that, I see negative infinity to negative 1 with a square bracket, union 1 to 4, square bracket, square bracket. So now it is clear that the answer is D.